right, Thomas's 1.6, solving other types of equations. There are 4 types of equations he's got going here. Let's look at the first of them. 4x to the 4th equals 12x squared. We're going to do the zero factor property. This isn't super new to you. So let's get a 0. Bring this over. Got a 0, now we need to factor it. So let's look and see what they have in common. I see that they each have a 4. Let's pull that out. And they each have an x squared to give. So let's see what's left. If we pull the 4 out, we pull out 2 of those x's, we'll have 2 left. Minus, if you pull 12 divided by 4 is a 3, and all of the x squareds are sitting at the door. So we got a 0. Now we factored it. Now let's use the property that allows you to set each piece equal to 0. So here we'll divide by 4. And then in order to solve for x, we need to take the square root of that side. If you take the square root of one side, you got to take the square root of both sides. So we get a plus or minus 0. Remember, you put the radical on, so you have to consider both the positive and the negative version. But there's not such a thing as positive or negative version of 0. Over here, let's move the 3 over. And then again, to get x, we need to take the square root of x. If you take the square root of one side, you have to take the square root of both sides. That gives you a positive or negative square root of 3. It gives you 3 answers, sort of 4 if we have a plus or minus version there. And we were expecting 4 answers because we've got 4 is our biggest exponent. The second one, 2x to the 3rd plus 3x squared equals 8x plus 12. This has 4 terms on it. So this is going to be a factor by grouping problem. These are all old factoring. These 2 are old factoring problems. Let's move this over and move this over. Again, you only have one method, zero factor property. So let's get a 0 first. Now let's factor it. Remember, if you've got 4 terms, we don't put it into 2 sets of parentheses quite yet. We have to factor by grouping. We have to pair them up. So we're just looking at the GCF for these 2. They both have x squared in common. If I pull out x squared out of that x cubed, I'll have 2x left. Plus, if I pull out that x squared there, I got a 3 there. Bring down the minus sign. Look at what we've got in common here. Both of them have a 4 in common. And then we know that this needs to be in here. And if you don't feel like dividing it out, don't. Steal it. But then make sure it works. Negative 4 times 2x, good. Negative 4 times a positive 3, good. And now you're supposed to notice that these 2 have something in common. They both have a 2x plus 3. Grab the leftovers, x squared minus 4. And then you can still factor. This is the difference of 2 perfect squares. I've been gardening again. Sorry about the dirty fingernails. Oh. What are you going to do? X plus 2, x minus 2 there equals 0. So let's set each one of these equal to 0. 2x plus 3 equals 0, x plus 2, and x minus 2. Get a 2 there. Get a negative 2 there when you send it to the other side. Here we get 2x equals negative 3 when we send that 3 to the other side, and divide both sides by 2. So there are the 3 answers. We were expecting 3 answers there. All right, let's go to the second side of Thomas's paper. Second kind of thing we're doing here. Each one of our answers has a radical in it. So this is a new set of a new type of problems. Notice up there it says always check your answer. This group, when you start with a radical, you got to check your answers each time. And I'll show you why. You'll see that sometimes it just doesn't work. Okay, so we start with this. In order to get x by itself, we need to cancel out that radical. This is taking the square root. We need to square to do the opposite. Now, squaring and unsquaring cancel each other out, so we get an x, which is what we wanted. But if you do that to one side, you have to do it to both sides. And so we get an 81 out of that. The check, plug it back in there. Here's the original problem. Let's put our answer in there. And sure enough, the square root of 81 equals 9. That works. So 81 is a good answer. Okay, B. Looks like the square root of x plus 3 equals x. Here we had this radical isolated before we squared. We need this guy isolated before we square both sides. So send the 3 to the other side. So you've got the square root of x plus 3 equals x minus 3. Now we can square both sides. We need to get x plus 3 by itself. We need to pull it away from this radical, free it up. So we'll square it. Squaring and unsquaring cancel each other out, so we get x plus 3. That's perfect. That's what we wanted. If we square one side, we have to square both sides. This is a FOIL problem. This is x minus 3 times x minus 3. First, outside, inside, last, and combine those two middle terms. So we get x squared minus 6x plus 9 there. Again, once you see that x squared, you know you've got to go into factor mode. So we need zero factor property. First thing we need is a 0. This x squared is positive on this side, so let's bring everybody over to join him. So a minus x and a minus 3. So we get 0 equals x squared minus 7x plus 6. So there's our 0. Now let's factor. What two well, we needed negatives there because we needed the signs to match, and they needed to be both negative. What two numbers multiply to give you 6 that add together to give you 7? That's 6 and 1. So we've gotten the 0, we factored it. Now set each piece apart. So we get x equals 1 and x equals 6. We move those numbers over. We have to check both of those numbers. Let's start with the 6. Put it into the original equation. 6 plus 3 under the radical plus 3 equals 6. That's the square root of 9 plus 3 equals 6. The square root of 9 is a 3. 3 plus 3 equals 6. That's a good answer. Let's check the 1. So we've got the square root of 1 plus 3 equals x, which is 1. Square root of 4 plus 3 equals 1. 2 plus 3 equals 1, no. So that answer didn't work. So we've got one answer. We got a 6. So you only put in 6 as the answer. Two numbers wanted to be our answer, 6 and 1, but only one of them worked. All right, let's look at the last one in this group. The square root of 2x plus 19 minus x minus 8 equals x. Yeah, we're still good. This is very similar to this previous problem, to 2b. You want to get this radical isolated first. Plus 19, so we'll send this over to the other side, equals x plus 8. Now it's isolated. The radical is isolated. He's by himself on this side of the equal sign. So I'm going to square to get rid of him. If I square that side, I've got to square both sides. So squaring and unsquaring cancel each other out, and I've freed that up. Over here, this is a FOIL problem. X plus 8 times x plus 8. First, outside, inside, last, and combine those middle terms. So we get x squared plus 16x plus 64. Now we're at the same place we were at this previous problem. We need a 0, and the x squared is positive on that side, so let's bring the 2x and the 19 over to join the right-hand side. X squared plus 14x, and then 64 minus 19, 45. So there, we've got our 0. And you can move that 0 to the right-hand side if you would prefer it over on this side. No problem. So now let's factor. X and x, signs need to be the same and they need to be positive. What two numbers multiply to give you 45 that add together to give you 14? It's 5 and 9. Doesn't matter which one you put where. So we got our 0, we factored. Now use the property that allows you to separate each one out and set it individually equal to 0. So we get a -5 and a -9 out of that. Let's check them both. Square root of 2 times -5 plus 19 minus 8 equals -5. So this is -10 plus 19. Not liking that so much. Oh, never mind. Okay, brain fart. Okay, we're good. Equals -5. So this is the square root of 9. This is 3. 3 minus 8 equals -5. Yeah, that's good. -5 is a good answer. Let's check -9. So we've got 2 times -9 plus 19 minus 8 equals -9. Putting in -9 in place of the x's in the original equation. So we've got -18 plus 19. We've got square root of 1. So 1 minus 8 equals -9. Nope, doesn't work. So we keep one answer and lose one answer. Okay, so that's those three of that type of problem. The third type, number 3, is the third type. Notice that all three of them have exponents that are fractions. It's called rational exponents. Each one's a ratio. So let's look at those. Number 3, we've got x to the 3 halves equals 8. What we need to do is make this be x to the first power. So what we're going to do is we're going to multiply 3 over 2 times a fraction that will make it be a 1. So if we want that fraction to be a 1, we need to multiply that fraction times its reciprocal. So we're going to multiply 3 over 2 times 2 over 3. The 3 on top will cancel with the 3 on bottom. The 2 on top will cancel with the 2 on bottom. And that's exactly what we want to have happen. We want to end up with x to the first. So we've got our x to the first. If we multiply that side, if we raise that side to the 2/3 power, we've got to raise that side to the 2/3 power also. So we end up with 8 raised to the 2/3 power. You know that that means with a rational fraction, or with a rational exponent there, we can turn that into a radical, put 8 underneath there. The denominator is the index, so the denominator goes right there. And then once we get something for that, we'll raise that to the second power. You can put the 2 under here, 8 squared, or do it at the end. I prefer to do it at the end because I want to get a little number here first, then I'll start making it large. So cube root of 8, use your calculator. If you don't know what the cube root of 8 is, that's fine. Turn it on. You want cube root, so we're going to use this key here above the humpy. So, I forgot. Let me clear that. I've got to first let it know I want to use the cube root. So let it know that you're talking about cube root. Then second humpy, that 3 goes up where the x is. That's the index of 8 equals 2. So now we've got 2 squared, which is 4. So 4 is the answer. 4 raised to the 3/2 power will give you an 8. Okay, let's look at the second one there. We don't have to check these. 5x raised to the 3/2 power minus 25 equals 0. Let's, just like up here, we got this guy, we had this guy, we were given him alone, isolated. Let's do the same thing here. Let's move the 5 and the 25 over across the equal sign. First move this, always the thing that's attached by plus or minus. Comes a positive 25. Divide by 5. So we've got x raised to the 3/2 power equals 5. And now we're doing very similar to what we did up on 3a. We've got to get this x to the first power. So we've got to raise him to the reciprocal of 3/2, 2/3. Good, that gives us an x because a fraction times its reciprocal will always give you 1. Check it in your calculator if you're not sure. 3abc2 times 2abc3 will give you a 1. Whatever you've done to one side, you need to do to both sides. So we'll raise 5 to the 2/3 power. That puts 5 underneath there. The denominator is always the index. And then you can put the 2 right there, or, it's a 5 under there. Or you can put the 2 at the outside. Either one of those is fine. 3 is the index, 2 is the exponent that we raised the 5 to. If you do it this way, you're going to have to clean it up a little bit and put a 25 underneath there. So either of those answers, I believe, is good. Okay, let's look at C. We've got x raised to the 5/4 power minus 8 equals 24. Again, isolate this weird little guy by sending the 8 to the other side. So we get x to the 5/4 equals 32. Now you need to make this x to the first. That's our job, is to find out what is x to the first. So we're going to raise this to its reciprocal. 5/4 times its reciprocal will give you x to the first power. Whatever you do to one side, you have to do to both sides. So this rational exponent, let's put 32 underneath there. The denominator is always the index. And then let's raise our answer to the 4th power, to the numerator's power. You could put the 4 underneath here, but I don't even want to know what 32 to the 4th power is. 32 times 32 times 32 times 32, and then finding the 5th root of it. That's no fun. So let's pound it down to little bitty size first. So the 5th root of 32, remind you, let's see, let's clear this, put in the 5th root. Then second humpy tells us that we're doing the 5th root of 32. We're getting a 2 there. So it's 2 to the 4th. It's 2, 4, 8, 16. Or you can use your calculator. So we get a 16 for that answer. Okay, let's look on the back of this page. And look at the last type. We've got 2 types here. Okay. Let's see how that does. Let's look at x to the 4th minus 5x squared plus 6 equals 0. Let's see if tape doesn't help that. We're looking at 2 here, and on my paper we look at 3, I think. So we're going to look at quite a few of these. The first time through, it's not going to make a whole lot of sense. The second time through, it's going to make a little bit more sense. Third time through, you're going to be ahead of me probably. And third time through would be when we get to my video. So don't worry if this is not too terribly understandable to you at this point. Follow the steps. Okay, whenever this is called quadratic in form. I love that name. It's a quadratic wannabe. It really wants to be quadratic. But in order to be quadratic, that's got to be a 2, and that's got to be an x to the first. So we got to work on that. So what we're going to do is we're going to pick a new variable. I picked a funny, well, I didn't do this. The books pick a funny variable that you're not comfortable with, that you're not familiar with. I'll tell you why when we get finished here. We're going to let mu equal whatever sits behind the b. Right there is what it is, x squared. So I'm going to substitute mu, this funny little Greek letter that we've never used before, so it's going to stand out in our brains, for x squared, for whatever sits behind the b term. So let's start at the back and substituting this in. 0 will still be 0, equal sign, no big deal. 6, good. Plus sign, good. Oh, x squared. There we're going to use our funny little letter mu. Then a 5, then a minus. And now this x to the 4th is this guy squared. So if it's this guy squared, it's this guy squared. So we're going to have a mu squared in front. You'll always have a mu squared in front. Always, always, always. You always have a mu right there. You create that. This piece will always be squared version of what sits here because this will always be the squared version of what sits there. They'll give them to you like that. So what we have now is a different variable, but we know how to do this. This is now quadratic. So 2 sets of parentheses. Signs need to be the same and they both need to be negative. What 2 numbers multiply to give you 6 and add together to give you 5? That's 3 and 2. So we've got 0. Now we factored. Now use the property that allows you to set each piece equal to 0. So we get mu equals 2 and mu equals 3. Now this is why we're using mu, this funny little letter, because I don't want you to stop and say, okay, I'm done, because we've never stopped with mu. We don't use mu. That's not a place to stop. Because you substituted mu in place of x squared, we have to get this problem back in terms of x squared, of x's. So we're going to have to undo the substitution that we have done. And every time you find a mu, put in an x squared. So there's a mu, I'm going to put in an x squared. There's a mu, I'm going to put in an x squared. Now I'm back on x grounds, which is what I needed to be, because this is an x problem and I need to land at an x answer. So just like we were doing in the previous problem, if you have x squared, you want to take the square root of that. If you take the square root of one side, you have to take the square root of both sides. So we end up flagging all of them. Squaring and unsquaring cancel each other out. Because you put the radical on, you need both the plus and minus version of that square root of 3, or that, yeah, square root of 3. Same thing here, plus or minus square root of 2. So we have a plus version of radical 3 and a minus version of radical 3. That's 2 answers. 2 answers here, a plus version and a minus. So we get 4 answers, which is what we were expecting. Right, let's look at B. 3x to the 2/3 power minus 11x to the 1/3 power minus 4 equals 0. Same game, we're going to substitute in a mu for this. And what we want to do is grab that piece, whatever sits behind the B term. So we're going to substitute in a funny little letter that we don't know anything about, that we've never seen before, just to remind ourselves that when we get here, we're not done. We've got to undo our substitution. So we'll let mu equal whatever sits back here, x to the 1/3 power. So let me start at the back. We've got a 0, no big deal. Ooh, got a 4, got a minus sign. There's our first substitution. In place of x to the 1/3, we're going to put a mu, then an 11, then a minus sign. And now this guy is times 2, this thing. So we're going to do this times 2, mu squared, and put a 3 there. Now this is no longer quadratic in form, it's actually quadratic. 2 there, an exponent of 2 there, an exponent of 1 there. So we've got the 0, let's do the factoring. Signs need to be different. What will make 4 times 1 is going to make 4. It won't be what will add to 11 because whatever we put here suddenly gets multiplied times 3. So whenever you've got a not 1 right there, it makes it a little trickier. Okay, I want to get some close to 12, so I'm going to put the 4 back there and put the 1 there. That way my outside is a negative 12 mu, my inside is a plus 1 mu. Good, that's exactly what I was going for. So this is correctly factored. So let's see, I got a 0, I did the factoring. Let me set each piece equal to 0. So I've got mu equals negative 1/3 and mu equals 4. Remember, that's not a good place to stop. That funny letter mu that is like, what the hell is that anyway? We've got to undo that. This problem started out about x's. It needs to end up about x's. We need to find out what x is, not what mu is. So let's resubstitute to get back to x's. We know that whenever we see a mu, we're going to put x to the 1/3. So let's do x to the 1/3 equals negative 1/3, and x to the 1/3 equals 4. I'm going to do the second one first. I'm going to mess with this one first. I think it's easier for you to see. Just like what we did up a little while ago, what we need to do is get this to be x to the first. So I'm going to have to raise x to the 1/3 to its reciprocal. The reciprocal of 1/3 is a 3. So 1/3 times 3, or 1/3 of 3, is x to the first. That's cool. That's what I want. I want x. But if I've raised that one to the 3rd power, both of them got to be raised to the 3rd power. 4 ABC, or sorry, not 4 ABC, 4 Humpy 3 will give you 64. So there's one of our answers. Over here, same game is going to be played. If I want to get that 1/3 to be a 1, I've got to raise it to the 3rd power. 1/3 times 3 gives me an x. But if I've done that to one side, I have to do that to both sides. And you can put this in your calculator, but a negative raised to the 3rd power is a negative. 1 raised to the 3rd power is a 1. And 3 raised to the 3rd power is a 27. So we get those two answers, negative 1/27 and 64 are our two answers there. And that looks like that's it for Thomas's.